Yo, 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 this is Mr. O, and today we're going to learn about conic section, chapter 9. Conic section, imagine that you have a perfect cone, an ice cream cone, and you have a flat knife. If this flat knife, imagine it cut straight across the tip horizontally. This is your knife here, and this is your ice cream cone. It will cut and it will form a circle. And let's say you tilt the knife a bit so it cuts through one side and exits the other. Now, this is a tilted cut. You make here an ellipse. And let's say you cut parallel to one side of the cone, um, the knife slant the same way the cone wall does, then that's where you make a parabola. And when you cut the cone straight down through both sides, then and you cut the knife vertically, you form here a two like a parabola, which is called hyperbola. And these are the four main parts or figure you can illustrate the conic sections. And today we're going to focus first with parabola. What is a parabola? It's a set of all points in a plane that are same distance from the given point called focus. We know parabola is a graph of a quadratic equation or function, but now we look at it in a multiple ways, but not only a function, but it could be an opening upward or downward and also sideways. They're all parabola. And on this way, you will imagine that this, let's say you have a point called focus. The distance of this focus is equal distance to from that point to the directrix. What is the directrix? Let's read the parts of a parabola. Let me show you this way here. So if I have a parabola here, we know we call this one as the vertex. The pink one is the vertex. We all know that. And this is the axis of symmetry. And somewhere in the axis of symmetry is called the focus. Focus has that is the point where it is equal distance to any point in the parabola over its directrix. So if this is 5, let's say, the distance of this to the directrix is a horizontal line or is a line opposite to the parabola. This one here is supposed to be also equal to 5. Okay, so if this focus is 3 units away here, this should be also 3 units away. They're always going to be the same. Likewise, if this focus is equal to 4 here, this has to be equal to 4 also. And also here has to be also 4, and that has to be 4. Okay? That's how important the focus is. And based on the definition given here, a parabola is set of all points in a plane that are the same distance from a given point called focus and a given line called directrix. And you will see here in this picture that the directrix is on the back of the vertex. So if my parabola goes this one, this is my directrix. If my parabola opens downward, where do you think is my directrix? Be above it. If my parabola opens to the left, my directrix is on the right side. If my parabola is opening to the right, my directrix is on the left on its left. Okay. Um, Going back here. So if this is my parabola, this is my axis of symmetry, and this is my focus. Again, one more time, if this is 8 from the vertex, the distance here is 8, then my directrix to this point here has to be also equal to 8. They have to be equal. And we normally call this letter A, letter A. Later on, you will see the formula for that one, okay? But what's important, you know that they are the same, okay? Now, this side here, from this focus to this one here, the pink one here is called the latus rectum. Latus rectum is the length. Here is the length from this point of the parabola to the other, passing to the focus. Okay, if this one here is 4, this has to be 8, and this is 8. Double of that one. Okay. What else you need to know? Yep. Focus directrix. Okay, good. So, now, what we will use vertex form as y is equal to a quantity x minus h squared plus k, wherein h and k represent your vertex. Sometimes, again, this sometimes the vertex can it will be the same as h and k, but sometimes the parabola, I mean, opens sideways, and there will be a little changes on the form, which I'll explain to you in a while. But making sure that you understand, if this is a vertex form, the standard form is in this kind of setup as y is equal to ax squared plus bx plus c. Okay, the book may have called differently, but for today we will ignore the book. Okay, so you won't get confused. For us, this is a vertex form, this is standard form. Okay. Another way of writing this down is that some textbook will have it, or references might have it, write it y minus k is equal to a x minus h squared, wherein the k has been transposed to the other side of the equation. And it's still the same thing. This is still your vertex, this is the k. Okay. All right. In this case here, let's state the vertex and the direction of the opening. What we're familiar with is if it's y is equal to x squared, if y is by itself and the x is the one with the squared, this opens upward. If y is equal to negative x squared, we know this opens downward. So if we return it vice versa here, this is the x and this is the y squared, this time the graph or the parabola opens to the right. And if this is negative y squared, this is opening out to the left. Okay? So let's state first the vertex. What is the vertex in number 1? This is the h and that's the k. If you say the vertex here is 2, comma 1, you are correct. And this is opening upward. Okay? Because the y is by itself and the one with the squared is the x. Number 2, x equal to 2, y minus 3 squared minus 3. This time, x by itself, the one squared is y, so therefore it goes sideways. Since this is positive 2 here, it opens to the right side. So this opens to the right. But the vertex here will be negative 3, comma, positive 3. This is the h here, and this is the k now. Agree with that? Okay, good. Next, this one here is y equals 3x squared minus 5. Y is by itself, x is squared, so you know it opens upward. And since this one here has no movement to the left or right, so therefore the x coordinate will be 0, but it will go down by 5. I want you to pause the video and try to check if you can do number 4 and 5 correctly. All right, there you go. So x is here in number 4, negative 2 times the quantity y plus 7 squared plus 13. X here is by itself and the y is being squared. So therefore, this opens sideways. But since a here is negative 2, so it opens to the left, like something like this. And the vertex here, the y coordinate is 13, and the x coordinate is 13. The y coordinate will be negative 7. Same thing with number 5. X is by itself. Y is being squared here. There's a plus 0 right here because there's nothing. And since this is positive, this opens to the right. And the x coordinate will be 0. and minus 1 as your vertex. So let's try this problem here. Y is equal to negative x, let's say here, plus 1 squared minus 1. Okay. All right. Okay. So in this case here, we know that the y is by itself and the x being squared. So we know this opens downward. 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 Okay. The vertex here will be, this is the h and that's the k. The vertex here will become negative 1, negative 1. Y-intercept here. We learned before the 1-3-5 pattern, right? Which is still gonna work. Down 1 over, down 1, 2, 3 over. And that's still gonna work because this is equal to a is equal to 1 there. The graph will still be the same thing. Okay. Or if you don't like that one, we can draw table of values and we still get the same point here. Okay. Now we know that the y-intercept is 0, comma, negative 2. Okay. Now the axisymmetry is this line here that passed through the vertex. So the axisymmetry is x equal to 1. Okay. Now focus. How do we get the focus? This is where it gets interesting now. Okay. I need you to pay attention here. Okay. So we will go back there. Okay. So again, the formula for parabola using the vertex form, y is equal to ax minus h squared plus k. Wherein a that talks about so many things. The direction if it opens upward or downward. A also defined that 4p is equal to a. What's p? P is the distance. P is the distance from the vertex to the focus. That is tell you how the distance from the vertex to focus. Okay. On this case here, if for example, if my example is say 8x minus h squared, let's make it a real point here. Let's say this is minus 2 squared plus 3 here. So I know my vertex here will be at 2, 1, 2, 3, at 3 there. That's my vertex, right? It opens upward. That one opens upward because 8 here is positive. But how far or where can I find my focus? You know that 4p is equal to a. That's a very crucial formula. So 4p is equal to 8 in this case here. And if you divide it by 4, p is equal to 2. So therefore, I know that p is the distance from the vertex right here to the focus. So since I know that this one here is 2 comma 3, if I go, and the focus is always somewhere inside the parabola, I need to go up by 2 here because the p is equal to 2. So this is 3, 4, 5. So my p, my f, I mean my focus right there, which is 2 units away. The difference of this 2, the vertex and the focus is 2. If that is 2 comma 3, then my focus will be what? 2 comma 5, because the distance should be 2 units away. Make sense? And likewise, where's my directrix here? Okay, my directrix should be 2 units away also from my vertex. 1, 2, which is this red line here, which will be that one is x, no, that should be y is equal to 1, because the distance of the vertex to the directrix has to be always equal to the distance of the vertex to the focus. Does it make sense? Okay, one more time. Make sure it's clear to all of you. So y is equal to, let's say here, think 12, negative 12. X, say plus 2 squared minus 4, or plus 4. We know here that the vertex here will become negative 2, positive 4, right? And we know that the formula for the distance of the vertex to focus is 4p is equal to a. In this case here, your a is negative 12. So 4p is equal to negative 12. So therefore, since it's distance, we have to keep it absolute value here. So this is really 4p to 12. P is equal to 3. That means the distance of the vertex to your focus has to be 3 units away. Make sense? So if we graph it approximately left negative 2, up 4. So left 2, 1, 2, 3, 4. That is my, I'm going to use a different color. This is my vertex. Okay, that's V as vertex. Okay, so now since that's negative, you know this opens downward, something like that. Something like that, approximately. Okay. So first, where is my focus? The focus is always inside the cave of the parabola. So therefore, I know it's somewhere right here. Will be somewhere in this area. I can locate my focus, and somewhere behind it, somewhere right here in this blue area, should be my directrix. Okay. Since I know the distance is p equals 3, and my vertex here is, what was my vertex here? Is negative 2 comma 4, right? So I know I'm gonna, and this is negative, I'm gonna go down 3 units. So 1, 2, 3. This point here should be my focus. And that then the coordinate of my focus now will be negative 2 and 1. The distance of negative 2, 4, and negative 2, 1 is 3 units away. Make sense? So that is my focus. Now, how far now is my, how can I get my directrix now? We know from V, vertex to focus, is 3 units away. It should be the same distance, 3 units away to my directrix. If this is 4, 5, 6, 7. So my directrix should be this line here, which we know it is 3 units away from my vertex. So that is 4, 5, 6, 7. So my directrix is y is equal to 7. Okay, so now let's apply that one to the real problem here given. Going back, so I know now that the value of my a here is negative 1. And now the formula is 4p is equal to absolute value of negative 1, which we know is going to be 1. P there is equal to 1/4. So we know that the graph will go down by 1/4 to find the focus. If my vertex is negative 1, negative 1, I will go down by 1/4 because it opens downward because it's negative 1. So the focus will become negative 1, negative 1 minus 1/4, or it will be negative 1, negative 1 and 1/4. Or we can say negative 1 and negative 5/4. That is my focus. Okay. It's 1/4 away, somewhere maybe right there. Okay. And we know if that's 1/4 away from the vertex, the directrix should be 1/4 away also from the vertex. So if my vertex again is negative 1, negative 1, I'm going to move up. So I'm going to add 1/4 here, which will become negative 3/4. So the negative 3/4 somewhere right there, that is my directrix. So my directrix is negative 3/4. My focus is negative 1 and negative 1/4. Okay, there you go. Next example. X equal to 2, y plus 1 squared minus 2. So we know that the vertex is at negative 1 for the y and negative 2 for the x. Negative 2, negative 1. There you go. We have already set up there. X is by itself here, y is being squared, so we know this opens sideways. But since a is positive, so it opens to the right. We can do the 1T5 pattern here, but it's times 2. So we know that, or what do we know how to find the x-intercept? To find the x-intercept, the value of the y must be equal to 0. So x equal to 2, 0 plus 1 squared minus 2, x equal to 1 squared minus 2, x equal to 1 times 2, 2 minus 2 is 0. That means it's going to hit the origin here. Or like again, instead of 1 doing 25, since the value of a is 2, you use 2, 6, 10 here. So instead of going up, you go write 2 over and write 6 over there, and that's how you're gonna get the uh, x value there, okay? But again, it goes sideways, so we're gonna do reflection. You're gonna go this side too. So our graph will be something like maybe this way, okay? Now, so going back, so our x-intercept is at 0, 0. Axisymmetry would be this yellow dotted line that passed through the vertex. That is x. No, no, that's not x. That should be y is equal to -1. Now, our focus is somewhere right here. That's a focus. But we have to know what is our p. 4p is equal to 2, so the value of p is 2 over 4 or half. That means the distance of your directrix or your focus is 1/2 away from your vertex. I'm going to go to the right. If I'm going to go to the right, I'm going to impact the x value. Since my vertex is -2, -1, going to the right, I'm going to add half to the x value, so or to the h. So -2 plus half will give us what? This is -4 over 2 plus half. That will give us -3 over 2. So my focus now is -3 over 2 comma -1. Same level for the y. So somewhere right there, okay? While my directrix is right behind it, somewhere right on this side there. But I know it is half away to the left of the h of my vertex, which I know the h is -2. I'm going to subtract 1/2 because I'm going to the left. So that is -4 over 2 minus half. That tells me it's -5 over 2, somewhere like 2.5. So this is approximately my directrix, which is x is equal to -5 halves. And there you go. That's how you graph a parabola from a vertex form. I. What about if you're given this kind of problem? Write each equation in vertex form, identify the vertex, axisymmetry, and direction of the opening. This time you are given a standard form. For this case here, you have to write it in a vertex form using completing the square. So what do we do here? So 3x squared minus 6x. Pretend that there's an equal sign here also. I put it first to the other side. So I put a 4 here. And you need to factor out the 3 here. 3x squared minus 2x plus blank is equal to 4 plus blank. What will be the missing number here? If you remember how to complete the square, the formula is b over 2 squared, wherein the b here is the -2 over 2 squared, which will become -1 squared is equal to 1. So this will be 1. Now we able to make this one as a perfect trinomial. But the only problem is what do we add here? Since that's 1, and there's a 3 here, you're going to multiply that one, so you're going to add 3 here. So therefore, when you look at this part, you can factor that to x minus 1 squared. What two numbers, when you multiply them, gives you a 1. When you add them, gives you a -2. It's -1, -1. Drop the 3, and then the 4 plus 3, which is 7, will swing back to the left. That's why it becomes -7. And that is your original equation now that transposed from standard to vertex form. So allow me to write it down here. Y is equal to 3, x minus 1 squared minus 7. Okay, let me erase this part. So what is the vertex here? We know the vertex here will be 1, -7. The axis of symmetry here is x equal to 1. The direction here is going to the, since y is by itself, x is squared, it opens to the up, opens up, right? There you go. Okay, so for your work today, I need you to graft the following. Okay, number one, I want you to graph the following. Number one, graph y is equal to 4x minus 2 squared plus 3. Number two, y is equal to, no, let's change it now, to x equal to negative, say, uh, 12 here, y plus 3 squared minus 1. Okay? And number 3, y is equal to, say, 2x squared minus 8x plus 3 here. All these three things, please graph them. Number one, I need you to find the direction, vertex, axis symmetry, focus, of course, directrix, and yeah, that's it. Please graph them all. For number three, I want you like it to write also the vertex form in order for you to graph precisely. Vertex, yeah, that's it. Okay, I hope you learned something. As always, kaboom.